So, if you were present in class and took the test in class, they're graded and entered.
Yes.
Overall, pretty fine. I noticed that it tended to be a pretty good match between, the amount of time and care we spent on our note card on the prep day and the performance on your test. You guys that were locked in and kind of did a good job on that tended to do a lot better. Something to keep in mind going forward on those review days to really take advantage of that class time and try to get things figured out as far as what you know and don't know, and ask some questions and get some answers and get some feedback. Today we're going to be starting chapter 3. If you are just dying to see your most recent test, you can talk to me outside of class time, and I can find it and let you look at it, but I'm not going to pass anything back until all the makeups get done. Just to let you know. So we have, between the two classes, a couple of, half dozen or so makeups that need to get done. Some of them are already done, but just letting you know that that's why I'm sitting on them, even though they're done and graded. And that's typically what I'll do. So if you want to see it, if you're like, oh, can I see this? I want to look at it. I have to talk to blah, blah, blah. I get it. All right. So my plan for today, we're going to start talking about chapter 3. In chapter 3, we talk about sine, cosine, and tangent as functions. Now that we can do sine, cosine, and tangent on any real number, we have the ability to now turn these into functions and talk about them the same way we talk about functions. So in this chapter, there'll be 3 kind of primary skills. Now there's sub-skills associated with these things, but 3 primary skills that we're going to be looking to do. You want to be able to take an equation involving sine, cosine, and tangent and turn it into a graph. Be able to take a graph of sine, cosine, and tangent, turn it back into an equation. And then the highest level version of this is going to be take selected information from a graph and be able to turn that back into an equation. So those are the 3 capstone skills for this chapter. Now there's sub-skills associated with doing those things. And there's some vocabulary and some other stuff kind of along the way. But those are the big 3 skills. If you can do those 3 things, you should be all set. Everybody okay for starters? All right. So on the board here, the first thing we have is, that is the graph of the sine function. And you look at that and you're like, great googly moogly, how the heck do we get that thing? Let's work through that here together on how the sine function gives us this. Okay? So to do that, I'd like you to pull out your unit circle. So, if we think about the sine as a function, our input, or the x-axis, is that angle theta, right? And on the unit circle, how do I find sine of an angle? What's the unit circle definition for sine? It's the y-coordinate from the unit circle, right? So my output on my on the y-coordinate on my graph is going to just be the y-coordinate from the unit circle. Everybody's okay? So find for me the zero angle on your unit circle and read for me what sine of 0 is. So look at your unit circle.
0.
Find 0 angle, and the y-coordinate at 0 angle is
0.
0. So I'm going to plot the point 0, comma 0, right? Because we have theta slash, or theta comma, like y-coordinate. That's what we're plotting. Everybody, so far so good? Mm-hmm. If I look at my x-axis, my next tick mark is at 0.25 pi. Or as a fraction, that would be 1/4 pi or pi over 4. So on your unit circle, find the angle pi over 4. That's same as 45 degrees. What is sine of pi over 4? Great, so I'm reading the y-coordinate there, which is the square root of 2 over 2, which as a decimal is 0.707 if I type that into my calculator. So I plot pi over 4, comma, root 2 over 2, or 0.707. Everybody okay there? So we did 0, 0. We plotted pi over 2, root 2 over 2, which is about 0.707. That zoomed in a little bit. Okay. So our next spot, our next tick mark is at pi over 4. I'm sorry, 0.5 pi, which is 0.5 is the same thing as what fraction? 1/2. So the angle we're looking for here is 1/2 pi or pi over 2. What is sine at pi over 2? 1. That's a typo. So I plot pi over 2 and 1. You see what's happening here? Okay, we keep going. The next is 0.7 pi or what angle? 3 pi over 4. What is the value of sine at 3 pi over 4? Root 2 over 2, so another 0.707. You guys get the idea at this point?
Yeah.
So if I keep plotting, I have 0 or pi comma 0, 5 pi over 4 negative root 2 over 2, 3 pi over 2 negative 1, 7 pi over 4 negative root 2 over 2, and then 2 pi 0. And if I just go around, they keep going around and around the unit circle, I keep repeating that wave over and over and over again. Does everybody feel okay with what I did here? And I could do the same thing for cosine. I could do the same thing for tangent. And I'm just going to keep getting graphs like this, right? Now, we're not actually going to, when we start graphing transformations of this, we're not going to actually do it this way. We're going to simplify this process down. But I think doing it once where we're reading the values off the unit circle and plotting them is helpful to just get a feel for, like, what am I doing? What am I shortcutting through when we look at that process of graphing here next lesson? Okay? Today's going to be a lot of, like, vocab and some definitions and, like, reading an equation and being able to identify some of these key features just by looking at an equation. And that's what I'm going to do next, is I'm going to describe the key features for a graph of sine or cosine. FYI, these kind of graphs like this that have a wave, kind of look like a wave that go up and down and up and down and up and down. We have lots of different names for that type of function. You could say that function oscillates, like moves up and down. You could call it cyclic, because it like repeats the cycle over and over again. You could call it harmonic. That's like a physicsy kind of phrasing for this. Or what we're going to call this is all the graphs of this shape, we're going to call sinusoids. So you'll hear that word repeated quite often in this class. So we'll talk about sinusoids. It's just a graph that has that wave shape. Okay? When we talk about sinusoids, we want to talk about the 4 key features. And I'm not going to describe these 4 key features in words. I'll describe them in words, but I'm going to define them with a picture, because more often than not, that's going to be what's really helpful to us. Okay, so I'm going to just kind of draw them in on this graph in different colors and just kind of write down what I'm talking about, okay? So the first key feature we're going to talk about is called the midline. The midline is going to be a horizontal line that divides the graph evenly above and below the line. So it just kind of cuts it in half vertically. Everybody's okay with that? So if I look at this graph, what horizontal line is going to divide this graph so I have the same amount of graph above it as below it?
X equals 0.
Oh, you mean y equals 0? Yep. But the x-axis, so the midline, we should be able to pick out with our eyes, right? I'm not doing anything sneaky to do that. We'll talk about if you're not given a picture and you're given a description, what you might do to substitute for not having your eyes. But if you have your eyes, you're just kind of picking it out of the picture, right? Because usually our eyes are pretty good at seeing where that would be. Yeah? The next thing we're going to talk about is, for the next key feature, is the amplitude.
So the midline's the x-axis?
In this picture, yes. So it's the line that divides the graph in half vertically. So you have the same amount of graph above it as you do below it. Does that make sense?
Yeah.
Okay. The next thing we're going to talk about is the amplitude. And that is just the distance between the midline and the highest or lowest spot on the graph. So there's lots of places where we could measure the amplitude, right? So again, that distance is the amplitude. It doesn't matter where I read it from. Since the amplitude is a distance, what kind of number am I always going to be talking about? A positive, right? Positive for distance. Everybody good with that? In this graph, what is the amplitude? Well, if you look, the tick marks it by a half, so it's 1 unit is what we've traversed. I know it's kind of small, I'm trying. I have a lot of stuff to be able to write in though. So far so good? Okay. The next is the period. So the period is a horizontal distance, it's the length horizontally of the longest non-repeating section of the graph. So what you do is you kind of pick a start point. So maybe I picked my start point here at 0, 0. If I look, the graph goes up, the graph goes back down, and it returns back to the midline. So that distance is 1 period, where we've gone from 0 to 2 pi. So in this case, it's 2 pi.
Wait, how do you determine how far you're going to go period?
So it's the length of the longest non-repeating section of the graph.
Oh, okay.
So I went midline, I went up, I went down, and then returned back to the midline. That's, if I do that after I start going back up again, that's repeating stuff I already did over here. So I'm done at when I get back to the midline. Now, do you have to measure the period that way? Sometimes it's easier to go, if you're looking at the picture, to go from like high to high, or from low to low, right? Or some other spot to the other corresponding. It doesn't. You can measure your period from any starting location. Is everybody okay with that? And you'll notice each time, if I go from negative 0.2 or negative 2.5 to negative 0.5, I still went 2 pi units. If I go from 0.5 pi to 2.5 pi, I still went 2 pi units. The period is the same length no matter where you measure it from. It's constant. Cool? And then the last one, the last key feature that doesn't really have a graphical analog is the frequency. And this is the amount of period per 1 unit length. Really what you want to just think about is it's just going to be the reciprocal of the period. So if the period is 2 pi, the frequency is 1 over 2 pi. So I'm getting like 1 2-pi of a period in 1 unit. So like a sixth, right? 2 pi is like 6.28, yada, yada, yada. So like 1/6 of a period, I get 1/6 of this up and down in 1 unit distance. I get about a sixth of it. Is everybody okay with that? So if you're given a picture, it should be relatively easy to pick these things out, right? You're just reading it from the graph. You know what the things are. If I can look at the picture, I can like draw in the midline, and it's like y equals whatever the y coordinate the horizontal line passes through, right? Once I have the midline, I can count up or down my tick marks to my highest or lowest point. I can count from high point to high point and get a period. Once I have the period, I can just take the reciprocal, and that's my frequency. If I have the picture, it's very easy, right? Nothing to do. What I want to do next is we want to work up towards, how do I do this from an equation? So if all I have is the equation of the function, can I get this information from just looking at the equation and not having to graph it? Probably, yes, we will. So let's go that way. So last year, you guys talked about like parent functions and transformations of a parent function, right? You guys talked about this. So like when you talked about quadratics, we talked about like y equals x squared as the parent function, and your general resultant function then you said was something like this, right? I think you call this vertex form of a quadrat. Does this ring a bell?
Kinda.
Okay. So we're going to do the same idea now with a sine and cosine function. So y equals sine x or y equals cosine x are going to be our parent function. We'll talk about tangent later on in the chapter. We're going to ignore that one for right now. So our resultant function is going to be y equals a times sine 1 over c times x minus h plus k, or the same thing just with a cosine instead of a sine. And these are like your resultant function. In Algebra 2, did you guys, when you looked at parent functions and their transformations, did you guys describe the transformation in words based on what the equation for the looked like? Like a vertical stretch, or a translation left or right, or up or down. Does that ring a bell? Okay, fairly. Let's recap how to do that then. And then we'll connect this idea back to what we've been talking about with the key features. So there are 4 basic types of transformations. Does anybody remember any of the 4? Mark?
Shifts.
So shifts we call translations, so you can shift up and down, left or right, that's a translation. You said compresses, so that's a type of dilation. You can have stretch or shrink. Those are types of dilations, that's 2. Rotation is 3. The last one is, if you look in the mirror, you see your reflection, that's 4. In this class, and in high school in general, you're never going to deal with the rotation. So we're going to talk about the other 3 here. And it turns out that I can look at the values of the A, C, H, and K, and just from looking at what those numbers are, be able to tell what the transformation is doing. I'll turn that a little cold. All right. Yes. Yes.
Definitely the first two, the 14 would be. No, it takes civil rights.
I was thinking about that
Next hour.
You guys don't have our class. I have the same teacher as you then. Nope, same class, different test.
Yeah, newbie hates their class.
Because it's
Yeah. And Saratoga.
I'm buying another one today, I don't care.
It's so sad.
His house? Yeah. Oh, yeah, you're Indigenous citizens' rights.
That's a lot.
Yes.
For K is less than 0, does it say shift down 1?
That's absolute value of K.
Oh, okay.
So you can't shift negative units. That doesn't make sense. The down is taking the negative.
all these
Gonna, 1 second. Okay. All right.
I only need one.
So we have this criteria that allow you to describe what's happening to the parent function just based on looking at the equation of the transformation. This set of criteria you will use to answer homework questions. If I ask in the homework to describe the transformation words, we're talking about using this set of criteria. On the test, if I ask you to describe the equation words, you're going to do it using this set of criteria. If you don't have it memorized, what should you do? May that be an excellent note card thing, along with the general form, so you know what the heck A, C, H, and K mean, or how to get those values, what we're talking about. Yes? Sure. I'm going to pause here in place, because I know I wrote a lot of stuff, and I see a lot of people still copying. We'll do an example in a moment of pulling those values, the A, C, H, and Ks, and doing this description here in a minute. Before I do that, though, I want to talk about the those key features and pulling that information from the equation too, and we'll do those things together in one set of examples. Okay? So we'll do some example using this in a minute. But I want to do some other stuffs first.
What articles do the classes test? What articles did the test? Charles, there's a bunch of articles on it.
There was like
Probably the Articles of Confederation,
Yeah,
you know.
stuff like that.
It's like a document, not an actual article.
Well, yeah.
the first of the second.
I didn't know some of
the
them.
amendment.
I know the amendment. Charlie said you didn't know the Articles of
How
Confederation.
many amendments?
Just like
No,
no
it's
one three something.
You need to know up to 26.
There's only 27.
Yeah.
Well, that last one,
There's
you
only
guys,
15 on the test.
Yeah, there's only 15.
I only
There's
know
only
15, but she pulls them at random.
But I don't have that.
That's actually stupid.
No, it's only the ones you go over. I never over something.
Yeah, so you need to know the Bill of Rights, 13 through 13, 19,
I know those.
21, 22, 24,
I can just guess those.
25, and 26.
All right.
That much.
let's, seems like we're kind of got to an end here. So just as a reminder, when we looked at our parent function, this is what we read off when I looked at the key features on sine, right? The midline was at the x-axis, that's y equals 0. The amplitude was the distance between the highest or lowest point and the midline. I said that was 1 unit. The period was the length of the longest non-repeating section of the graph. That's 2 pi, regardless of where you start counting at. And the frequency is just always the reciprocal of the period. So what I want to do is I want to take that information, think about what I know about transformations, and use that to figure out how to tell what the midline, amplitude, period, and frequency will be for any resultant without having to actually look at the picture, where I can just look at the equation. So if I think about the midline, is reflecting the graph across the x-axis going to change the location of the midline?
No.
No, right? Because if I reflect it, you still have the same amount of stuff above as below, right? What if I vertically stretch the graph or shrink the graph? No, right? Like the midline stays the same, the graph just gets the same amount above it as it did before. You know, like it's going to be fine. What about a reflection across the y-axis? If I flip it that way, don't affect the midline. What if I stretch or shrink it this way? No, right? The midline stays still dividing the same amount of stuff above and below.
Yeah.
What if I shift the graph left or right? No. What if I shift it up or down?
Yes.
Yes. So that up or down shift is controlled by K. It turns out that that will just give us the equation for the midline, y equals K. So if it was at 0, I shift the graph up 4 units. The midline's going to have to shift with everything else to stay in the middle. So it's got to shift up 4 units also, for example. Does that feel okay? Should feel really natural, right? That midline is stuck relative to the rest of the graph. If you pick up and move the rest of the graph up or down, the midline has to come with it. If we move it left or right, though, the graph goes forever in both directions. So does the midline. So moving left or right doesn't really do. Feel good? Okay. Amplitude. So let's think about the same thing. If we reflect across the x-axis, is that going to change the amplitude? No, right? Because the distance doesn't change when it reflects. You know, just what was high up here becomes low down here. What was low down there becomes high up there. It's going to be the same thing. What if I vertically stretch the graph? Is that going to change the distance between the graph? Yes. And that's the one that controls it. So the amplitude is just going to be the absolute value of the A. So again, the A is this number out front. When we talk about the A, H, and K, we're all talking about the coefficients in our resultant function, our transformation. Does everybody feel good there? Okay. Period. That's the horizontal distance. If I reflect across the x-axis, is that going to change? If I stretch or shrink vertically, is that going to change it? No. If I reflect x and or across the y-axis, is that going to change it? If I stretch or shrink vertically or horizontally, is that going to change it? Yes. So that's the one that controls it. So the period is going to be 2 pi times the absolute value of c. Again, we use the absolute values on the A and the C here because amplitude's a distance, has to be a positive number. Periods of distance is a length, has to be a positive number. So that we just do the absolute values of A and C to knock out any negatives because the A's and C's are coefficients. Those can be negative. It's okay for K to be negative because y equals K is an equation. A negative value for K just means that you have a horizontal line that's below the x-axis. That makes sense to me. And if the frequency is just the reciprocal of the period, and we know the period, there we go. Now, do you think that these key features are something you guys, or how to find these key features? Is this going to be something we're going to use?
Yes.
Yeah. If you don't memorize it, where should it go?
No card.
No card. And again, I made the suggestion last time, I don't think anybody really took me up on it, to maybe start writing your note card as you go. So you have like a rough draft of it already on the review day to build from.
So what exactly is PF?
Parent function, resultant function. So like the parent function is the original, the resultant function is what you get after you do a transformation. Is that?
Yeah.
Okay. All right. So this is going to be now what we're going to be using to do all the subsequent examples that I'm going to do. Okay? Today, all we're going to work on is being able to pick out these key features and write a transformation and describe a transformation. Okay? That's all we need to do. Deal?
Deal.
All right, let's rock and roll here, huh? Yes. Short. All right. So we're gonna do like 3 versions of this, 3 examples. I'm gonna do the first one, talk you guys through it. And I'm gonna ask some of you guys to help me do the subsequent examples. Okay? Gonna get you guys involved a little bit more. Everybody okay with the tempo we're going at? Nobody feels left behind? Seemed like by the time we got to the review day, people felt left behind. I'm trying to be a little bit more careful and deliberate with what we're doing here, as to not do that again. But you gotta let me know if it's like things speed up and you're like, whoa, you did a whole bunch of stuff there and you lost me. Okay? All right. So I'm gonna do 5 things here. Ian?
Should it be x minus 3?
That's the function that I've written.
Okay, got it.
So this is just an example. So we're gonna do 5 things. I'm gonna write the 4 key features, I'm gonna find the 4 key features, and then I'm gonna write the transformation in words. Everybody's okay? All right. Before I can do either one of those, what I have to be able to do is pull the values of A, C, H, and K from the equation. So what I like to do is just kind of below where I'm working is to just remind myself what that general form looks like. Oops. So that's just the general form, the resultant function. And I think from looking at this, it's usually pretty obvious that like A is 2 and -1 is K. What's usually the tricky part is figuring out the C and the H from the stuff on the insides. Is everybody okay with that? All right. So I'm going to go ahead and do this like really slowly and deliberately and write down maybe way more than I need to in an effort not to leave anybody behind while I'm doing like a little bit of algebraic manipulation here, okay? So if you're looking at this and being like, it's obvious what the H and the C are, fantastic, you're so far ahead. I'm going to go really slow because I know that not everybody is going to be in that same spot, okay? So the first thing I'm going to do is I'm going to take this 3x and I'm going to think about there's nothing added or subtracted at the end of that 3x, correct? So I can write like a -0 there. Everybody feel okay? The next thing I do when I look at this general form or the resultant form is that I need the x to have a leading coefficient of 1. So I have to factor anything off that's in front of the x, right? So I notice in this example, there's a 3 in front. So I'm going to factor that 3 out. When I factor a leading coefficient out like this, or when I factor a coefficient out, what I do to find the stuff that goes inside my parenthesis is I divide, right? So 3x divided by 3 is x. And then 0 divided by 3 is 0. Is everybody okay there? Okay. So at this point, now let's get rid of the blue. I can see that the H has to be 0, right? You guys see that? Pick the bad color, huh? It's all right. It's too much work to change it now. We're just committed to it. Everybody's okay? The issue, though, is that now I have to figure out this. 1 over C is equal to 3. But I don't want 1 over C. I want just C. If 1 over C is 3, what does just C have to be? What did I do to the left-hand side of this equation to make C? Madison? What?
Is it a one?
Yeah, there's a 1 at the bottom. So what is it called what is it called that I've done here?
The reciprocal.
The reciprocal. So what am I going to have to do to this side?
C.
The reciprocal, right? Is that okay? That I just took the reciprocal of both sides of that equation? So 1 over C equals 3 becomes C over 1 equals 1/3. So I can say 2 sine of the quantity 1 over 1/3 times x minus 0 minus 1. Now this is in the exact same form. Is that okay with everybody? Yes. Yeah. So the takeaway here, what's the relationship between the coefficient on our x and our value for c? The coefficient on our x and the value for c. What is the relationship between them? They are reciprocals. So do I have to go through this rigmarole every single time? Or do I just remember that the coefficient on the x, the reciprocal of that is my value for c? That's the way that I remember it. It's the same way every single time. You don't have to do the algebra every single time because it's going to work the same way every time. And like, I can make the reciprocal of a number, Mr. Kulik. That's pretty easy. Right? We can all do that. Comfortable?
Yeah.
Flipping fractions. All right. So I have A equals 2, C equals 1/3, H equals 0, and K equals -1. This skill that we just worked through of being able to find the values for A, C, H, and K is the core skill in Chapter 3. Everything we do is going to require, almost everything we do in this chapter is going to require you guys to be able to pull those values from an equation. If you can't do that competently, it's going to plague you the entire chapter. Okay? It is a fundamental skill. We're going to give you guys chances to practice this in just a minute. But I'm going to keep going and finish this example out. So, my midline is y equals k. So in this case, y equals -1 is my midline. My amplitude is the absolute value of A. So in this case, my amplitude is 2. My period is 2 pi times the absolute value of C. So in this case, my period is 2 pi over 3. I just did a fraction. Is everybody okay with how I got the 2 pi over 3? Is that okay? You see it? 2 pi times 1/3 is just 2 pi over 3?
Yeah.
For sure? Okay, I'm going to keep going. the frequency is just the reciprocal of the period. So my frequency then is going to be 3 over 2 pi. Right? I just flipped my period.
So essentially what we're doing is we're just finding all the letters, and then we plug those letters into the
Formulas from above.
formulas to find like the form you can out of it.
That's it. That's all we're doing. The hardest part is getting the letters. Plugging them into the formulas is easy. Getting the letters is the most challenging part. And really it's just the C and the H that we have to be careful on. Okay? And then if I want to do my transformation, so the first thing I look for are any reflections in the vertical direction. Nope, right? Because A is greater than 0, so we have no reflection across the x-axis. But A is greater than 1, so we have a vertical stretch by a factor of 2. My C is greater than 0, so I have no reflection across the x or the y-axis. That's bad looking penmanship, Mr. Kulik. And because my C is between -1 and +1, why I have a horizontal shrink by a factor of 1/3. My H equals 0, so I have no shift. Oh, I did Euro case first. My K is less than 0, so I shift down 1 unit. And my H equals 0, so I have no horizontal shift.
Yeah. So do we need to write 1 and 2 for each letter because you wrote all of the no ones, or do we need to just write the ones that like it does?
You should get in the habit of writing the no's so that you remember to check for a reflection, even if it doesn't happen, or check for a left and right shift, even if it doesn't happen. On a test, I wouldn't mark you down if you didn't include it, but I think it's a good idea on the homework to include, like, nothing happens for this type of transformation, because it gets you in the habit of making sure you're looking, right? Because it's easy to forget something if you just are in the habit of only writing down the things that do happen. It's easy to miss one. Does everybody feel okay with how I did that? Right? I just used these values and looked up at the criteria that we wrote down earlier and checked if something happened or not, right? And there's 6 things that I have to check. 6. Right? Reflection, X or Y. Stretches or shrinks, X and Y, or horizontal, vertical. Shift up or down. Shift left or right. That's the 6 things. So usually, like on a test, I would have like the numbers 1 through 6 listed, and if you don't use it, you can just like leave that spot blank or whatever. Or you could write nothing happens, but there's always 6 things to check. Cool? All right, you guys ready to try some? All right. We'll do this one kind of, this next example kind of together. So I'll ask for you guys to answer things. We'll walk through it kind of together as you guys answer. I'll tell you if it's good or bad or right or wrong or close or, whatever. And then we'll give the last one will be, I'll give to you guys to try, and then we'll write out the answer, and you can kind of check your own at the end. Deal? Okay. You know what? Let's make that a 4 first. We'll save that nasty thing for the last example. Not step too far. So I'm just gonna try to add a little bit of complexity each time on the example. Putting a pi there is probably one step too far. We'll do an intermediate one before we put that pi there. The next one I'll put it there though. All right. Hannah, we've written in the general form underneath it. Can you find one of either A, C, H, or K right away for us?
Is C root or negative root?
Not C, right? So you're looking at this -3 here, right? What letter is at the front of the general form?
Oh.
A. So yes, A is -3. Madison, can you get C, H, or K?
A is +1.
K is +1. I agree with that. Angelina. C and H, no, Adriana, sorry, wrong sister. C and H are a little bit hidden from us right now. You agree? Because they're somewhere in this 2x + 4, but that doesn't look like this, right? What do we need to do to the 2x + 4 to make it start looking like this? Okay, so the first thing we need is to get that leading coefficient on the x to be 1, like it is here. Right now, our leading coefficient on the x is 2. How do we fix that? So the reciprocal is going to be related to finding c, but I'm asking you a different question right now. So you're not like out of the ballpark, but you're playing like a different game than I'm playing right now with you. So how do we take something like 2x + 4 and get it to look like something times parentheses x minus h? What is it called when I take something that looks like this and make it look like that? Remember what that process is called? Starts with an F. Factoring, yes. So what do you have to factor out of the 2x + 4? It's going to be whatever the coefficient on the x is. So a 2. When we factor that 2 out, what's going to be left? close x plus 2. Thank you, Adriana. Tell your sister I said hi to her in class today, or tried to call on her today. You would tell her it's a good thing she wasn't here. I don't know if she would have known the answer to that question either. Nick. So we've done a little bit of work here, right? Our issue is that this inside doesn't look like that inside, so we can't read it quite off of what we had. Would you like to work on, so there's two issues now, right? This needs to be like 1 over something, and this symbol here has to go from like a minus to a plus. Which one do you want to work on? No, well, we have two issues, right? We need to somehow rewrite 2 as like 1 over something, or we have to write plus 2 as minus something.
The minus.
Which one do you want to try to fix?
Wait, why do we have to change the 2 into something? Because are we just doing half of 4? That's already 2.
We'll get to you in a second. We'll see. I'm just waiting on Nick here, and then I'll circle back to you, Joe. I don't have, you're coming up next, so.
I can't really see, to be honest.
Okay. So I need to, let's say let's do the first part, right? I need to write 2 as 1 over something, right? Specifically the 1 over c. Do you remember what the relationship between the c and that coefficient on the x was that we talked about earlier? Adriana remembers. Do you want to tell him what the relationship was between c and that coefficient on the x? It was the game you were playing before when I told you we were playing the wrong game. The reciprocal. So 2 and c are the reciprocals. So what that gets you then, Nick, is that our C is 1/2. Okay. Joe Lancy.
Yeah.
All right, we got one thing left to do.
Yep.
In our general form, we should have x minus h. In our problem, we have x plus 2.
Yep.
How do I resolve that plus 2 and make it minus something?
You have to put a minus on the outside. No, we do. Minus on the outside.
So we need a minus,
Yeah.
but it's going to be adding 2 is the same thing as subtracting negative 2,
Negative 2.
right? So that's the trick.
Oh, okay.
Right? And then we can see that the h has to be negative 2.
Yeah, that makes sense. I'm a little confused about the half part. Because are we just trying to get half of 4? Why does it turn into 1 and 1 over 1/2?
So what we need is I need to rewrite 2 as 1 over something so I can see what the c is. The c is the something, right? So I have that 1 over c is 2. if I want just C, I do the reciprocal of C and the reciprocal of 2, and that tells me the C is 1/2. So I can write it then as 1 over C, which is 1 over 1/2.
Okay.
Is that
Yeah, it makes more sense than I.
okay? Again, the hardest part is getting the C and the H correct, right? The relationship is the coefficient on your X. The C is the reciprocal of that every single time. The H, you have to be careful, right? If you looked initially, maybe the H is 4, wrong. Or the H is -4, wrong. You have to make sure that you're factoring that leading coefficient on your X off. Then you look at the value that's left, and you have to take the opposite value of it, right? If we have +2, H is really going to be -2. Every single time that'll be true for the H. So you have to make sure you factored the inside first, and remember to do that correctly. And then the H is going to be the opposite sign of what it looks like when it's left, because the minus is already part of our general formula. Okay, so far so good? All right, Jacob. We have now amplitudes, midlines, periods, and frequencies. Can you tell me any one of those 4?
Okay. So, for midline,
Yeah,
we have to do, I'm just looking at the, okay, we can do this. Midline can just be +1.
okay. So you're very close. I'm going to be picky about this so when it comes test time. If you write down the midline as 1, I'm going to mark a deduction on that. Because the midline is not a number, it's an equation for a line. So it needs to start y equals, and then 1 is great. So again, I'm letting you know
Oh,
now
I see how you did on the last problem.
where it's like no stakes, but that's something I would be picky about. Like I would mark a deduction on that. I wouldn't give you full credit because it's not the equation of a line,
Yeah,
it's just a number.
got
You
it.
see the distinction though?
Yeah, no, but
Everybody else caught that? So remember, for midlines, you gotta start y equals. You might as well write that in as soon as there's a midline question, right? Y equals before you even answer it, so you don't forget it. It's easy to make that mistake, but I am gonna be picky about it. The things I'm gonna be picky about, I'm gonna tell you in advance so that you can practice watching out for it. Ellie, you got 3 left, amplitude, period, or frequency. Can you tell me one of these?
I can't even see it. Is the amplitude -3?
It's not -3, but it's related to -3. It's +3. The amplitude is the absolute value of A. The absolute value of 3, or -3, is just 3. Everybody happy? Mark, you're up.
yes.
Period or frequency? This is kind of a no-brainer, right? No one's doing frequency before they've done period.
Period.
Yeah, what is it?
So period is 2 pi absolute value of C, right?
Correct.
What? Well,
2 pi times the absolute value of C.
so 2 pi times 1/2
2 pi times 1/2, which is just going to be
pi.
pi. Great. Ian, frequency.
Would it be? No. Yeah. Wait, hold on. So isn't frequency just a reciprocal of period?
Correct.
So it'd be 1/pi.
1 over pi. Looks great. Everybody feel good on that? So far, so good? Okay. Let's do our transformation now. I'm going to shrink this back down a little bit. Hi, Coach Whalen. Yeah, you're coaching now, huh?
Can you hand those to those guys during CT?
Sure.
Thanks so much.
No problem. All right. So Tessa, you're up, right? You want to do what happened? Well, tell me what everything for the A. What transformations come from the A?
A is less than 0, so it reflects across the x-axis.
Yes.
And then A is less than -1, so it's a vertical stretch by
And then we should say
or factor of -3.
by a factor. Well, it's absolute value still.
So 3.
Close to 3, right? You can't have a factor of a negative number. It doesn't make it. But great. Wonderful.
And C is greater than 0, so there's a reflection across the y-axis.
So C is greater than 0. So there's no reflection for positive C's.
Okay.
Negatives make the reflection. But you're pretty good. Keep on going.
Should there be a horizontal shrink by 1/2?
Great. Because the C is between -1 and 1. Brady, you want to give us what happens from the H?
Yeah, no. I'm lost right now.
Okay. So we're using
I know the chart.
this set of criteria. So our H was -2.
So it'd be
So I look here.
less than 2. So no shift?
Well, H is less than 0, right?
Yeah.
Because -2 is less than 0.
Oh.
So we should say shift left 2 units.
Not -2?
Right, because the left covers the negative part.
Oh, okay.
Right,
Yeah.
shift left.
Okay.
Does that feel okay?
Yeah.
All right. And then our last one, Luco. It's the K. Yep.
K is greater than 0,
Good.
so it'll be shift 1.
Good. Shift up 1 unit.
Oh, yeah. I read it wrong. You said, oh, yeah.
What do you guys think?
Super.
This is going to be what the homework looks like. Just doing this.
Super.
I just have the chart out.
The homework is 1 through 4.
Watch out. I'll put it on my soul, I didn't do that either. Doesn't matter, I need to review.
That's it.
86 on the test.
So ideally, I would have had a third example. We ran out of time, so this is what we're calling it.